endpoint exploitation, abusing local admin accounts, and lateral movement. And this will be presented by a team, Patrizio, Donato, and of course Gil, that will take us through the tech steps. Patrizio, I will move the floor to you to allow you to start presenting the second scenario.
Okay, thank you. Can you hear me?
Yes, we can hear you.
Okay, for the second scenario, I just need the introduction slides that I can see right now. Okay, I don't see the slides, but probably you can see it. Welcome back. I'm Patrizio Rinaldi. I'm a senior technical specialist, and it is my pleasure to introduce briefly the second scenario. Also, this scenario is divided in two parts, the attack and the defense part. For the attack part, Gil, once again, help us to show you how once you gain the control of a single workstation within a targeted environment, you can move laterally and escalate privileges in order to grab information about the infrastructure and obtain access to the full list of the account and related password. For the defense part, we will show you how is it possible to prevent this attack by using the defense ecosystem offered by Microsoft that consists of a security solution that natively integrate to address every aspect of an attack chain. Also, for this scenario, we used egg tools, and please consider the use of this for demo purpose only. Okay, I pass the stick to Gil.
Okay, thank you, Patrizio.
I'll pass. Gil should be the presenter now, and you can take us forward through the tech steps.
Thank you. Hi. So in the next demo, I'm going to show you what are the implications of a single machine that is being compromised in your organization, how this foothold can be leveraged to additional attacking steps until the entire organization is being compromised. So in order to do so, I'm going to use a very nice utility called Armitage. If you are familiar with the Kali Linux, the most famous utility in Kali Linux is Metasploit, and the Armitage is actually a user interface, a GUI that sits on top of Metasploit and enables you to visually see the attacked machines and the different attack techniques, and allows you to easily perform these attacks. It pretty much converts the art of hacking into script kiddies game. So I've started the Armitage server on my Kali machine. This is a server client module, and you can have multiple users connect to your server and multiple hackers simultaneously, and you can have a team effort. So I started the server here in my Kali machine, and the client is started here. So this is the Armitage user interface. It's a very nice interface, user and hacker friendly. On the top right, you can see a list of different machines in the network. On the left part, these are the attacks that are that you can execute, and at the bottom, this is the information that is relevant for a specific attack or for the console in general. So in a real life scenario, the first thing that we would do is to perform a reconnaissance, and this is true for both external reconnaissance to gather email addresses, for example, for phishing, and as soon as I get an internal foothold, I will perform an internal reconnaissance as well. So in order to save time, I've just activated the scans already, and you can see here a list of all of the assets of the internal networks, including printers and many other machines that are part of this network. And in order to start the second demo, I'm going to show you a phishing attack, but this time a phishing with an attachment, a malicious attachment we're going to see on the victim's machine. But first, before I start, let us just activate the handler, the listener that would listen to the attacks that takes place. Sorry. Okay, so I'm going to activate the listener. This is actually the port that listens to the victim's communication, and as soon as someone connects, I select what should happen. So I'm going to select the Meterpreter payload. This is the standard utility that is part of Metasploit and is used by Armitage. This is a command shell with a unique command shell of Metasploit that enables you to run commands on Windows machine. It is more advanced than regular shell, Windows shell. So I'm going to select this option, and I'll configure the rest of the configuration. Okay, and I launch it. You can see it's very simple. Attack, few parameters, launch, that's it. All of the commands are entered by Armitage. So the listener is activated, and now let's go to the victim machine. So I'm not going to send the phishing email once again. You already saw in the first demo how easy it is to create a phishing website, and there are other tools that enables you to send phishing emails with attachments. So in this example, I already sent this email with this attachment. You can see this is a fake email that looks like it's arrived from an internal user, and it contains salaries.docm document. Check out these salaries documents. People tend to be very curious about the salaries of their colleagues, and this is a fake attack that looks as if a fake salaries document was sent. Notice the extension of this file. This is not a docx file, a regular Word file. This is a docm file, which means it is macro enabled. The attack actually takes place because an Office macro is embedded within the Word document, and this enables the attacker to execute commands on the victim's machine. If it is not hardened, there will be no alerts whatsoever. If it is, there will be alerts. So in this example, let's just use this phishing email and open it up. Attention, this document was created with newer version of Microsoft Office, and as soon as you try to enable macros, then you are being attacked. There is no sign for the victim that anything is wrong with his machine. And when we come back to the attacker machine, you can see that now I took over his machine. You can see that the screen is turned from gray to pink red with lightings, and this actually shows me that I've taken over this machine, and now I can try to do many things to this machine and to select the payload that should run on this machine. So the first thing that I would do, you can see the different options here, and interpreter, etc. Okay, just a second. Okay, so I can open a command shell, for example, just to have a look at the different of the environment of this machine that I just took over. So this is the IP address of the machine, and I can check, for example, what is my current user, but this is already information I already know. I can also try, for example, one first thing that we would try to do is to activate the NSLOOKUP command. This command contacts the internal DNS server and will try to dump all of the information from it. So let's try to do it. Okay, query refuse in this example, and later on we would see in the monitoring capabilities of the network that this was that I was trying to perform a DNS enumeration in this example. So this specifically does not work, but I can do many other things in addition. So first thing that I will do is to perform reconnaissance of the internal network, and also to dump interesting information from the specific station. So I have the same privileges as the logged in user as the victim. So obviously I can log to an email and to maybe steal information from his emails. And you would be surprised to see how many people send passwords, cleartext passwords in their emails. And another thing that I can try to do is to dump passwords from this machine. And there are several techniques of doing so. I can, for example, dump hashes. If you are not aware what a password hash is, this is a mathematical algorithm that enables you to mask the password. This is a one-way algorithm, unlike encryption, regular encryption, which is two-way. You cannot go back theoretically from a password hash to the original password, to the cleartext password. But this is only theoretically, because there are techniques of breaking hashes and getting the original password, like brute force and dictionary attacks. And in some cases, I can even use the password hashes themselves in order to authenticate to other services. So the first thing that I would try to do is to dump passwords from this machine. And when I try to do it, you can see that the hash dump process fails. Why is this happening? This is because I'm currently using the user 5 privileges. He's a local admin, but he's not a system user. System user is a stronger user. This is the strongest user in the system. So I need to migrate my capabilities and the process that I'm controlling to a system process. So let us see all the processes. And I can, for example, select this one. You can see this is a system user, a local system, and I can migrate to it. Okay, that's it. Now I'm a system user. And let's try it once again. Sorry. And now the operation succeeded. So now I have the different hashes of the passwords that are stored inside this machine. And I can also try, for example, to use other techniques. For example, digest. This is an older technique that tries to get clear text passwords, not the password hashes. And if this is an old Windows machine, for example, Windows 7 and not Windows 10, in Windows 10 it is also possible, but not at the very the latest version. So if it's a patch Windows 10, digest dump won't work. But because this is a Windows 7 machine, let's try it. And now you can see clear text passwords as well, not only password hashes. So all of the passwords that are stored as clear text in memory can be dumped from this machine. So now I got everything that I need from this specific machine. I scanned the network, I have my credentials, and I need to move on. And I want to, for example, take over another machine. So in real life scenario, we would probably use many tools such as Bloodhound. This is a very famous tool that enables you to map all of the networks and all of the users in the network and the correlation between them. This actually gives you a map of the organization that shows you servers and stations and the logged in users that are currently logged in to this server. And if you are able to take over any machine in the organization, you are able to dump the passwords of the logged in user in this machine, as we just saw. So the next step for me in the attack that is taking place is to take over a machine with a stronger user than user 5, let's say a domain admin user. So I will probably, in real life scenario, I'll probably execute the Bloodhound utility and map the entire organization and the stations that are currently logged in, and the users that are currently logged into these stations. For example, I can choose this server and try to attack this server as well. In order to do so, you can see I can try to, for example, use the PsExec technique. This enables the execution of remote processes in other machines as long as you give it the credentials. So let's activate it, and you can see here the different credentials. Here the credentials are already installed, but we saw earlier that we have this also. The thing is, with Armitage, this is a free utility, and every once in a while you have small glitches. In the here view credentials, you're supposed to see both the users and the passwords of the cleartext commands, and also the password hashes. And for some reason, it doesn't show it. So we'll select it manually. Okay. So you should have seen these credentials here as well that pass the hash, but we'll do it manually. You can see here there is a local admin that is called Antonio ADM, and this is the password hash of this local admin. And as I told you earlier, it is quite a common practice to use a local admin with the same password for all of the endpoints, and sometimes the server in the organization. This is for the IT department to log into to these machines easily. And I'm going to exploit it, and let us use this set of credentials in order to log into this machine, and I'll also select the password hash. Okay. In a few seconds, you can see now I control this machine as well. And I can do exactly the same thing that I was doing before. I can try to interact with it and to open command shell, for example. And now, in the last step, I want to migrate to a domain user, because as I explained earlier, I would probably the next target that I would try to attack is that of a server or station where a domain admin is currently logged in. So let us see all the processes in this machine. Oh, sorry, just a second. Let's do it once again. Antonio, can you please fix this part? Let's wait a few seconds until Antonio logs in. Antonio is the domain admin, and he's supposed to log into this server. Let's wait a few seconds. These things can happen in a real life demo, obviously.
So Gil, we are waiting for Antonio to log in parallel for the attack scenario.
Yeah, just a second.
Antonio, can you hear us?
Okay, let's try it again.
Yes, just a moment, please.
So before until Antonio is will do it, we can do exactly the same thing that we already saw in the first station. We can dump password. We can try to open command shell and perform NS lookup. We can do scanning from this computer. Maybe this computer has more access, more network access compared to other computers in the network. So let's wait for a few seconds. This is also something very nice. I can try to perform key logging and see if Antonio is trying to log in. And I can also take a screenshot of this computer.
Gil, can you try right now?
Yes, just a second. Oh. No. Sorry, I don't see it now. Again, this is a live demo. Let us see. So maybe the last step is a bit problematic.
So maybe we can go over the defensive part, and if relevant, we can come over to that once Patrizio is starting his part.
Yeah, we can come back later.
Okay, so Patrizio, are you ready to take over while Gil is?
Yeah, sure.
The floor is yours, and you can share your screen now.
Okay, thank you. Okay, introduce the defense part with just 2 slides. Because to respond to this kind of attack, we must shift our attention to the protection of the endpoint. Because we are in the situation in which, in some way, the attacker was able to deliver a file with a payload to a user, and therefore was able to bypass any perimeter defenses. The security and protection solution in this area is called Microsoft Defender ATP, and this is a solution based on the concept of real monitoring of file processes and application. So it's not a solution based on content scanning. This solution represents a multi-layer protection that operates against the endpoint, that integrates with all the infrastructure protection solution offered by Microsoft. I'm thinking about Office 365 ATP, Microsoft Cloud App Security, Azure ATP. Having a multi-layer protection of the endpoint means having multiple detection technologies in the same product, and most important, means to be able to integrate the capability of the agent, the sensor that runs on the workstation, with the power of the cloud services for the benefit of a more accurate detection. In Microsoft, we tell the story of next generation protection, which address the most advanced threats, fileless attacks, hardware breach, payload injection in business application. That's work together with the detonation techniques. I'm speaking about sandboxings, MCA engines for script-based attacks, network monitoring, memory real-time scannings. That's work together with the EDR engine and behavior analytics for the implementation of self-investigation and auto remediation operation. We also have a new technology to perform system hardening. This technology is called attack surface reduction, ASR, and allows the administrators to harden the operating system through policies that can prevent you from taking risky behavior. So let's move on the test machine. Can you see my screen? Yes. Okay. With this workstation, we will show you how the different component of the solution operates. Let's start by checking the real-time product engine. We made some exclusion. I show you in order to allow the demo to work. No, not here, but here. So we made some exclusion, and this exclusion allows me to, for example, copy a file that contains a payload, a malware, in this location on my payslip folder. This folder is excluded by the real-time scanning engine. I can extract the file, but let's see what's happened when I move the file to a destination that is protected by the engine. The file is immediately detected and blocked. And after the engine works against the file, we can appreciate that the malware part will be removed. In a few seconds, this file becomes smaller than the original. Now is 84 kilobytes, and here is 26 kilobytes. Let's move on the console that we provide to the analyst to know what is happening on the environment. This interface is the effort performed by Microsoft to integrate all alerts coming from different systems, different security systems. You can see Office 365, ATP, Microsoft Cloud App Security, Windows Defender RTP engine. All these alerts are used to consolidate the view in incidents. And when I open an incident, I can immediately appreciate the referral to the military attack framework, so I can understand where is the attacker within my my environment. I can see all the related alerts that are correlated to this incident. For example, this alert is coming from the EDR engine. The other one is coming from the antivirus engine. And also I can manage directly from this console the workstation, but not only workstation, the machine in this workstation is a domain controller. I can manage the workstation and the endpoint. Okay, something in the demo environment is happen. Machine and I can perform some tasks, administrative tasks, in order to remediate the attack directly through this console. For example, I can restrict the app execution, or I can run the antivirus scan. I can investigate the content of this incident. I can also isolate the machine from the network. Let me show you how works the isolation. You can maintain some process running on the machine or not. Performing the isolation, the PC immediately lose the connectivity, so I can contact the workstation through the RDP protocol. I can only interact with this workstation if I stay physically on the workstation or through this console. And I can initiate, for example, a live response session. A live response session is a session in which I can run some command against the workstation. I can remediate to my situation, to my incident, and then I can reconnect the workstation once the solution is solved. Okay. Waiting for this. I can release from the isolation. And the workstation now is once again online. Okay, let's move to the other engine that runs against this workstation. The other engine is called ASR, Attack Surface Reduction. Is a new way to perform hardening, system hardening, and consists in defining some rules that you can push on your workstation, on your server, to avoid some behavior. For example, you can define that a process cannot generate a child process. In this example, using the same file, you can see that this the execution of this content is blocked even if I run the file inside the folder that I excluded from the real-time scan. This behavior is because the other engine called attack surface reduction has blocked the application office from creating a child process. Let's move to the interface that manages this technology, the solution. In the interface, you can manage the configuration of the workstation, so you can immediately see what's the rule that run against my workstation, and you can manage the rule against the workstation, and you can grab eventually the exclusion that you want to make on your infrastructure. You can also check the detection that the engine made against your environment. For example, I can see that salary was viewed sometimes in my ecosystem. Opening the Microsoft Defender ATP page, I can also observe the details of the file. The details are reported here. You can obtain the alert related to this file. You can see the file names used to try to spread this file across your environment. And important is that you can add an indicator, so you can add and enrich your database with your personal IOC, and this IOC become shared with all the security solution that you run in your environment. For example, enriching your database with this action can allow Office 365 ATP to recognize this file when it's attached to an email. I can also stop and delete the file from the workstation and put the file in a quarantine, or download it to perform some analysis. For example, I can use sandboxes to analyze the real behavior of this file. When I go to the attack, the malware part, I can appreciate the details of the malware detection. I can view a consolidated view of how many times this file, this malware was observed worldwide and within my organization. But I can also see the process tree that was used to the file to perform the attack. And using the incident graph, I can see the relationship between the file, the workstation, the process that are running the attack within my organization.
Oh, perfect. Thank you. Thank you very much. Thank you, Yochai. Thank you, Gil and Patrizio. We'd like to continue with the story and provide you with other features that Microsoft provides within our framework. And this is, we will cover other features within Microsoft Defender ATP, and we'll have also an overview of Azure Advanced Threat Protection, which is a cloud service that helps enterprise hybrid environments from multiple type of attacks, cyber attacks, and insider threats. So GIL, during the attack phase, completed first action, which was reconnaissance. So the first step GIL was able to complete, and for the second one we can leverage other alerts we have in our environment in order to show you what we can grab within our services. So first of all, where we can start. So usually we start from our consolidated console, which is Microsoft 365 Security Center. This is our Microsoft Threat Protection Unified Console, where we can consolidate all the alerts. And here we can find the alerts, and from we can then navigate into the specific tool in order to go deeply and analyze the alerts. So coming back to the Microsoft Defender ATP console, here within the security operation dashboard is where we start. There we can have an overview of where the detection were seen and highlight where response actions are needed, for example. As you can see, we have a snapshot of active alerts, machine at risks, sensor health, and many other insights. We saw with Patrizio that we can leverage different tools. The first one was the incidents. We saw that incidents represents an aggregation of different alerts. We can go deep and manage those incidents. We can then prioritize those incidents. This is important. So within this part, we can manage all the incidents. The other tool we have, as we saw with Patrizio, is the alert queue. So we can start, for example, from an incident, and then open the incident page to get all the details we already saw, and then check all the alerts that were aggregated into these specific incidents. So we can go and analyze any incidents, or we can use directly the alert queue. So within the alert queue, what can we do? We can have a list of all alerts that were flagged from machines in our network, and by default, the queue alert displays the last 30 days incidents, but we can use the filter, all the filters we have, for example, filter by severity, status, category, and many other attributes that helps us to identify specific alerts. We can then investigate a single incident. So for example, we can go inside the incident, manage the incident, classify the incident, maybe provide a status, assign the incident, provide a classification, and from that page we have many details to go deep. And we can, of course, open the incident page, the alert page, and check what was the alert story. So in this case, we can check the process tree in order to understand what happened in our infrastructure. Another tool, interesting tool that we can use is the automated investigation and remediation. Automated investigation remediation is something that starts automatically because when an alert is triggered, there is a security playbook. So depending on the security playbook, there is an automated investigation that can start. For example, suppose that we have a malicious file within a machine, an endpoint. When we detect that file, the alert is triggered, and then the automated investigation process begins. And Microsoft Defender ATP checks to see if that malicious file is present in any other machine within our organization. And from this investigation, we can automatically apply a verdict, for example, if the file is malicious, suspicious, clean, etc. So, for example, going into the our automated investigation present in our environment, we can select, for example, this one. So we can see that an automated investigation started. We can see when, we can see the duration. The automatic investigation, if we open the details, we can see an interesting information. So the first one is an investigation graph that graphically shows us all the machines involved, the entities analyzed. The entities are files, processes, services, drivers, IP addresses, for example, in this example, alerts, and evidences. And we can go and drill down this investigation, showing the alerts, the machine involved, what are the evidences, and the entities. Last, we have the here the log. So here we can show all the logs related to the automated investigation. So we can sort by log ID, but we can also sort, of course, by time created. So here we can see what this automated investigation did during all the time. An automated investigation needs also an input from security operation analysts, and here we can see all the actions that the automated investigation asked us in order to continue with the remediation part. Another interesting tool that we provide in the response, detection and response part is the advanced hunting tool. So how can we proactively hunt a threat? We provide this tool, which is a query hunting tool that let us to explore the last 30 days of data. The foundation is the same that we use to query all the logs within Microsoft Cloud Solution. And it is based on a very powerful language, query language called Custo query language. We provide a lot of documentation on this language and how to use it. There are a lot of examples. And in this demo, I want to show a very quick and simple query where we can query the logs in order to find specific events related to a specific file using the hash of the file. So we can run the query and extract the data. And that's it. So this query extracts all the events where a specific file with a specific hash triggered. And as you can see, we can show you all the events, and from this list we can then go directly into the machine detail rather than the file details in order to react, let me say. So this was the application file generated by the Word macro that Gil executed. Okay, one more thing related to advanced hunting, because we provide a more complete view and a more complete possibility, because within the Microsoft 365 Security Center, we provide an advanced and consolidated, let me say, tool. It is the same tool, the same query language, but from this console, we can also, we have the possibility to create a more complex queries that spans through other logs. In the previous console, we could query logs within the machine. Here, from the Microsoft 365 Security Center, we can also query email logs, as you can see here. Of course, the device logs, but also the logs from our identity and access management solution, which is Azure Active Directory. So here we can aggregate different information and extract different information from different services. This is very interesting. And of course, this tool, with this tool, you can leverage queries that are shared by our community. And of course, you can also participate, creating your queries and sharing those queries to the entire community. Last thing that I want to show you is Azure Advanced Threat Protection. We saw before that during the Gil attack, there was a first tentative of enumeration within the reconnaissance phase. And what we wanted to show you was a desysync attack. So this desysync attack is a late stage attack, usually in the dominance phase. And we wanted to show you that after lateral movement steps, he gains access through a privileged attack. And these attacks allows the attacker to simulate the behavior of the domain controller in order to retrieve information like users, password, and other information. This is where our solution called Azure Advanced Threat Protection comes to identify this attack. So we can, for example, navigate from Microsoft Defender AD. So we can, for example, start from an alert within Microsoft Defender ATP, so I can take a specific alert. This one, where we launched an interpreter attack. As you can see, within the details of the alert, we crawl the page, and we have, as you can see, Azure Advanced Threat Protection alerts. There are some alerts. We can click and go directly into the Azure Advanced Threat Protection admin console. Here we can have a specific view related to this workstation, where we can see that those alerts that Gil triggered before, so this is the account enumeration reconnaissance alert on this machine. So here we have different information. Azure Advanced Threat Protection is a cloud security solution that uses signals from our local Active Directory to detect advanced threats through the full kill chain. So this is an alert from an early stage, of course.
Donato, you can try now to refresh the log. I just executed the attack successfully.
So okay, we can wait a couple of seconds, of course, in order to see this is sync. In the meantime, maybe I can use an old. Let's see if we see an old event related to this is sync attack. We can go directly in the main page of HTTP. Here we have first thing. That's it. This is an event triggered by Gil some days ago, and this is what we can see directly within the console. As I said, from the tool helps us to identify alerts from earlier stages to late stages, and this is something, as we said before, that we that is in the in a later stage. Okay, we also aggregate those logs into Cloud App Security, which is our CASB solution. And within Cloud App Security, we can see all the alerts related to the identity part on premises provided by Azure ATP. Here we can see the same alerts, and we can, of course, manage those alerts and react, of course. Another interesting tool integrated that shows you the integration between Azure ATP and Cloud App Security is the identity security posture. Here we can have some evidences related to a misconfiguration of our Active Directory. So from here we can see if there are some issues that we can then manage and in order to remove those kind of threats. This is another example of the integration of our solution.